Hello there. It's Mixer Rain. We're now in episode 31 of our Enigmatica 6 expert series, and today we're going to solve this issue of the cobblestone. We are going to start making our Cobbleworks. So let's take a look. Right now, today, we have a very vanilla cobblestone generator. We're able to specify what kinds of cobblestone we want to generate based on what's underneath it. You can also use iron blocks or diamond blocks to make smooth stone, right? However, this is a manual and slow process, so we're going to make some sort of automation for it. The automation I have in mind is going to use create, and we're going to create like a gantry system, and it's going to be controlled by computer craft. I do not envision that this is going to be the most efficient system. It's just going to be something fun to build and maybe fun to watch and look at, right? So that's what we're going to start with today. I do not think we're going to finish it. It's going to take a lot of materials. Specifically, let's go ahead and take a look. Computers, right? I'm going to need 9 computers to run the lines, and you'll see why a little bit later. But I'm also going to need 1 computer to run inside the machine that does our dispatching and whatnot. These take machine frames, which come from rough machine frames, which come from this whole process that we needed, if you remember, to make the storage drawer, which means coated machine frames, which means plastic, which means all sorts of things, right? This is really making me feel like we need to have automation set up for a lot of this stuff, like plastic. But my plan, the reason why we don't have the automation yet, is I want to... do we have it on us? No. The refined storage computer, I really want to use refined storage to get our automation going. I don't want to set up a temporary refined storage system. I want it to be in its basic spot right from the get-go, so we don't have to like pick up and pack up and move stuff around. So, off in the background, way behind us there, I'm thinking of making the storage room, and that'll be our main base of operations. It's going to be a very large building, because I want it to also have a lot of our automation stuff inside it. But that's going to take a lot of materials to build. Materials that I don't want to gather by hand like we were just doing in the cobblestone generator. So, we're going to start off with getting our other thing set up. And if you can see in the background, hello Mr. Golem, there is some scaffolding way over there. This is where we're going to set up our Cobbleworks. So, let's go ahead and get started. I want to use this really cool sheet metal siding and sheet metal paneling to create our walls for our building that's going to house our drawers for all of our new cobble. That being said, I need to make some of this. This isn't too hard to make. You have to make sheet metal plating, and sheet metal plating comes from sheet metal, which is just iron plates in a line to get this sheet metal. So, not crazy. We have the iron bees, so I shouldn't run out of iron. Next, we need to have 27 storage drawers because we have 27 different kinds of cobblestone that our system is going to gather. We're going all out. We're going to go ahead and gather all of the different kinds of cobble that there is because why not? That being said, there are some that I'm going to use a lot more than others. The weathered limestone cobble we've used quite a bit. The gabbro cobblestone, also quite a bit. The saffron tavertine, not at all, but we're still going to get a storage drawer set up for it. That way, we can have it as a building material if we ever decide that we want it. That being said, we're going to start off with the more common ones today. We're not going to probably set up everything. So, we're going to go start building our storage room for the cobblestone now. Alright, this is our layout plan. Hopefully it's not going to be too confusing. What I've done here, let's ignore everything in the back for now. We're just going to look at this line of scaffolding. These are where our drawers are going to be. They're probably going to be lifted up off the ground, of course, but this is where all of our cobblestone will be stored. This center piece here, this will be the drawer controller, which will connect everything underground through trim pieces. This will be our dispatcher computer. And then the 3 above, I'm thinking, will be a large monitor. Now, this plan might change a little bit because this might be too high to view correctly and be able to read. We'll have to play with that once we get into it. I'm really not sure if that's going to be a pain. If it is, we'll have to move this screen somewhere else. But then we're going to have, all of these over here. So we've got 4 on one side and we'll have 5 on the other side. That makes our 9 rows of 3 each. On the side of each one of these sets of drawers, we're going to have another screen, and that screen will detail how many, or what the item is, how many items are in it, how many the drawer can fit, and what our fill percentage is. Just some, you know, basic, easy to see information. And that's what this is going to be. So we're going to build a room around this, and this is our project for today. Hopefully, we can also get to getting at least one line going. So this over here, all this scaffolding back here, this is the layout for how much space we're going to need for our Cobbleworks. We're going to have, just take a quick look, this is 8, okay? So we're going to have a single line of 8 pieces of cobblestone for each different type of cobblestone. So this is normal cobblestone, this is the gabbro cobblestone, this is andesite cobblestone, or whatever, right? Something like that. And our system will move over, come down and harvest, move over, come down and harvest, and then go back and return, and everything will go into drawers. That is the goal for what this system will do. It's all words at the moment. Hopefully we get to see something in action today. So, without further ado, we gotta make a storage building. Okay, this is looking like it's going to be a very large building. That might be alright, but right now this is very plain. I wanted to lay it out pretty quickly, but you'll notice in my inventory I have rusty versions of the same stuff, and then also I have these paneling pieces which we haven't used. So let's go ahead and see what it looks like if we were to put a few of these paneling pieces in random spots. There, and here, and there, you know, just sort of all over the place. There's no reason why there can't be more than one in the same row, and I think that looks pretty cool, because it makes it look like the pieces, you know, are not, you know, just going on forever. So if we just kind of randomly space this out, I bet this will look pretty cool. And then we're going to do the same exact thing with the rusty pieces, because, you know, got to get some cool rusty look in here too. Got to really just try and break up any of the spots that look like they have too much plain. Okay, this is where we're at. I'm actually out of these building blocks now, and so there's a few holes. However, I did actually want to put some windows in, and so they might look something like this. It'll probably change a little bit, but you can see the rusting bits I think look really good on here. So I didn't want to like mix them up and put them in random spots. I wanted it to look like the whole section had rusted. Otherwise, it would look kind of weird that, like, why did it rust in a straight line across the top? But it would make a lot more sense if a whole panel piece rusted. So here we go. We have this all the way around, and we have just, you know, random rusty sections. I think it looks pretty neat. And then finally on the inside, we're going to have cinder blocks for this whole thing to stand on, because it's kind of look a little bit like a construction site office, which are usually like trailers. So the next thing we're going to do, we're going to get some something to come in here, and this will be our floor level, and then we'll have to get something for our roof level as well. And I'm not sure exactly what blocks are going to look the best, so we're going to have to play around with it just a little bit. Okay, we are going to make our first computer now. It's an exciting moment, although we're going to need a lot more in the future. We're going to, right off the bat, upgrade our computer to an advanced computer. Great. Let's take a little bit more in-depth look at what it takes to make a computer. This machine frame we've already seen, right? We've needed it for multiple things. This is where the plastic comes into play. This is where machine bases and advanced PCBs and reinforced stone slabs come into play. But if we come back, there's a few other things that we've really not seen before as well. A machine button. These are actually super cheap to make, not a huge pain at all. We have up here RAM chips or advanced RAM chip. So here's the advanced RAM chip. This actually requires a mechanism part, which we don't have the ability to make just yet because we need lithium dust. I don't think the lithium dust is hard to make, it's just we don't have a setup for it yet. So instead I went with the RAM chips, which are redstone relays, lead wires, or copper wires, and then circuit backplanes, which are all fairly cheap, just a slightly tedious process to make. Then we have the CPU core. The CPU core you actually make in the assembly controller, and very specifically, I think we want to look at like this one. This is the recipe I did. It does take an unassembled PCB, some improved processors, copper wire, and a cardboard box, interestingly enough, but that will make one CPU core. And then we have the graphics card. The graphics card itself, copper nuggets, heat sinks, which are compressed iron, iron bars and some copper, an advanced processor, the printed circuit board, and a turbine rotor. We're now going to set up our advanced computer and the drawer controller. First, we'll pop the drawer controller in right here. So now everything should be connected. So if I come in here, you can see I've already laid out, I think, where I want everything to go. There was a very specific way I laid this out, at least for the bottom row. This bottom row is going to be the closest row out in the field. The closest row, because it's closest, will be the fastest to harvest. So anything that I thought I was going to be using a lot of, we wanted to put on the bottom row. Then, because the second row is going to be the second closest, I did put things in there that I thought were going to be more useful than other things. And then finally, the most unuseful bits go in the back. And I also tried to keep the color coding, you know, a little bit. It's not perfect or anything like that. But if we right-click this drawer controller, we should see they're all now locked. That does give us the clear indication that we're all connected, which is perfect. So next, we're going to put the advanced computer right on top. These computers actually do not require power, which is pretty good. Now, if you don't have any sort of programming experience, you're going to have a slightly bad time with this mod. This mod is actually very much like using a terminal-based computer. I can do like ls to list where I'm at, or pwd. Oh, that's a Windows-only thing. Right? But what we're going to do is we're actually going to make like a directory here, make directory, and we're going to call it dispatcher, because this is our program dispatcher. And then we're going to change directory into dispatcher. We're going to see that there's nothing in here. And we're going to have to edit a new file, and then we're going to have to program it from scratch. So here we are, edit dispatcher. So now we're in a new program. Right, this mod doesn't have buttons to click and configurations to set. This is, again, literally programming, right? So we're going to do something really quick and easy to show you how it sort of works. And this uses the programming language Lua. So if I just do print, okay, and I hit tab to autocomplete, I'm just going to say print, hello chat, just like this. All right. And we're going to want to save, press Control, or click here to access the menu. Oh, the other thing too is the advanced computer, which is the golden one, does actually allow you to use a mouse and click. But here we go, and I'm going to save it. And then the other thing I can do is I can hit run to see it work. Look, this is what it did. It printed out hello chat. Press any key to continue. So let's go ahead and exit our program. The way that you would actually call this program is by calling it just dispatcher, because that's what we called the file itself. There it is. Hello chat. We're all here. We can all see the message. I'm going to spend a little bit of time, okay, writing up an actual program. And what it's going to do right now, right? We don't have a monitor. We're not displaying anything. We don't have anything to control. All this is going to do at this moment is it's going to talk to the storage drawer controller down below, and it's going to get a list of all the different types of items we have in there and what it contains. This might take a little bit. All right, I want to show you a little bit of what this is going to look like. We're going to have these monitors, except it's not going to be on this side. However, I wanted it currently to be attached to the computer. The other way that we're going to actually connect all of these monitors, because if we're going to have one here and here and here, the way that we would actually connect these monitors to the computer is, if I come over here and take a look again at the Computercraft mods, we need wired modems. So you need to attach a modem to the computer and a modem to the monitor. And then those are actually connected with networking cables. However, they're going to be a little expensive. They take aluminum sheet metal, okay, which isn't that expensive, but this is where we get expensive. We need more machine bases. More machine bases means more advanced PCBs, which means more plastic, more printed circuit boards, more of all of these things, which are a bit tedious to craft. And then we have the networking card, which also requires printed circuit boards, advanced processors, which are processor binding silicon, Andarium coin, and flux dust, as well as a wireless transmitter, which these ones aren't too bad, just being a lot of aluminum and some more advanced processors. So we'll get there. We don't need all of the monitors set up today. However, I wanted to show you a little example of what the monitoring system will look like. Not final. This is just a temporary thing. So we're going to take a look at what we have in our directory. Okay, so we have a folder called Dispatcher, which we saw that we created. So I'm going to change directory into Dispatcher. And then when I look in here, we have one program, and it's just dispatcher.lua. So this is what I've written. I'm going to run it real quick, and you will notice, okay, I'm gonna output some things in the console, in the terminal here, that will be displayed information about the drawer content. But you're also gonna see the screen back here change, and we'll take a look at the screen. It's gonna be really cool. So all we gotta do is run it, dispatcher. Okay, so I can't scroll in this window, so I can't go up to see anything else that was printed up here, but we can see we printed out limestone cobblestone. We have 49, there's 2048 capacity, the limit, and this is the percent full that the drawer is. Same thing with cracked limestone and its values, and saffron travertine and its values. So now if we leave, we can actually see that information right here. Right off the bat, you might notice that, yes, the names run off the screen because they're too long. I haven't decided if I'm going to try to do any sort of line wrapping or if we think that's okay. I could go either way on that. It's going to be a little bit of work if I want to do line wrapping. However, this does give us a very quick, at a glance, view, right? Because we can't see the values on the drawer unless we look at it, and then we get the values up on the top and we can see stack limit of 32 and all that kind of stuff. However, we can see that at a glance. I mean, I could be over here looking at these ones, and I could just glance over, and we could see cracked limestone has 21 in there, right? Just interesting like that. So we will have monitors next to all of these drawers, and that will inform us of their contents. My program is not complete, not anywhere near complete, and a lot of it is temporary. However, let me show you what it looks like. And please let me know in the comments, do you like seeing the code or not? Because we are going to do a little bit more coding, at least for this project. And if we like it, I'll probably do maybe more computer craft projects in the future as well. But if we do more computer craft projects in the future and you don't want to see the code, I don't want to show it. So we have to start all the way at the bottom. So at the bottom, we call the main function. This is the main function. And what it does... All right, this is our drawer controller. DC is drawer controller. We are wrapping the drawer controller. And what it means to wrap in this mod, it means to assign the drawer controller itself and the method calls that you can make to an object. So let's actually look at wrap drawer. This is a function call. So we're going to go all the way back up to the top to see the function. This is wrap drawer. The very first thing that we do is we check if there is a peripheral present at the bottom. So if we take a look, right, our peripheral is the drawer and it's at the bottom of the computer. So that would be correct. The next thing, if that was true, right, if we had a peripheral down there, we're checking, hey, if the peripheral is get type of bottom, and I gotta scroll over, if it's type storage drawer controller, this is actually the tag of the item, the tag name of the item, really. Then we want to say print drawer controller found at bottom, and then we return the wrap of that peripheral at bottom. This here, this is safety. I know that the drawer controller is at bottom, so I really didn't have to write all this code. However, if I want the code to be nice and reusable, this is really helpful. I don't know how far we're going to go in making it reusable. The code itself might just be very specific to what we're doing. And in fact, we will see some very specificness to what we're doing coming up, because I wanted to get something that kind of worked. So we have this lines object, and this is called a table in Lua. This is going to contain all the information of our lines. We define it in the main function. That way it is accessible to lower level functions, right? The scoping of this will be available lower in. So we have build drawer controller list. This function up here is building our information. So we have line 1, line 2, and this is going to correspond to the outside machines and what they're going to harvest. Remember, they're also going to correspond to the drawers. So this is line 1. We're going to lay out granite, red rock, and the persimmon, travertine, in a line out there, and that will be machine 1. That will be line 1. Same thing for line 2, line 3. I started on the right, going left. There's no real reason for that. I felt this was the first line, so that's why I did that. When we come back and look at the code, though, you will see these random numbers. They're actually not random. So line 1, what this means is we have drawer number 24, we have drawer number 27, and we have drawer number 28. These are the positions of the drawers in the internal memory of the drawer controller. So really what happens is the drawer controller itself scans out in a range, right? And it's scanning out sort of like this in the way that my cursor is moving. Actually, it might even be going this way. I'm not quite sure. But this is actually drawer 1, and this is drawer 2, and then I think this is drawer 3, and then this is drawer 4, something like that, right? So over here, this is our furthest away drawer, so it became drawer number 28. And you might say, you only have 27 drawers. That is true. In the drawer list of the controller, drawer 1 actually isn't a drawer. It starts with drawer number 2. Why does it do it like that? I don't know. But here we are. We have assigned the drawer position to each line. And after we do this part here, this is really this isn't reusable, right? This is very specific to my own code. We could absolutely over-engineer this and come up with a way to determine, based on the name of the item, and then create our drawer list saying, we would have to then say, yeah, drawer granite cobblestone is drawer number 1, drawer number 2, drawer number 3, and then we would do it that way. That would still not be super reusable. You'd have to probably edit a file and then read the file, and So we went with this. So after we create all of our line details, we insert the lines, table.insert. So this table is a function of Lua. And then, table is actually a global object that has functions on it. And so here's the insert. So we are inserting into a table, the table being lines, we're inserting line 1. And remember, lines was the table we defined way down here at the bottom. Right here, we're inserting all of our lines, line 1, 2, 3, 4, all the way up to 9, into this. After we build our drawer list, I'm just running this function called print line details. This will not actually be the function we call. This was for testing. How do we actually access the details? How do we use the details? This is what this is. So this is an example of how to obtain line details. It just prints the details for each line, for each entry in the pass in line. So you'll see, okay, this is important. When we call print line details, we are passing the drawer controller object to this function, and we are passing a very specific line. Lines 5. This means, right, that when I ran the function, line 5, 1, 2, 3, 4, 5, was this one, limestone, and we got the limestone detail, cracked limestone here, and we got the saffron. If I change this to be line 4, we will see weathered, tremble crust, and cobbled etherstone. Let's do that real quick and just see how it changes things. 4. Run. Look at that. Wow, isn't that pretty cool? It is pretty cool, because what this is going to let us do is we're going to be able to pass a very specific line to each monitor, right? This will be like, hey, this is monitor 5. You should pass me line number 5, and it will display the correct details on the screen. All right, so let's look back at that code real quick. Again, if you're not interested in seeing the code, I am sorry. Please let me know in the comments so I know if I should keep doing this sort of content or not. But what is actually happening? Well, we have to first wrap the screen. Remember, we had to do this with the drawer controller. So we know the screen is currently on write, so we have to wrap it. In the future, when we have them all hooked up with networking cables and wired modems, we will actually call them by name. They will have a name, so we will actually wrap. It'll be like wired modem 1, wired modem 2, something like that is what the name will be. And so we'll wrap those directly. We'll have to write a fancy script, I think, to say like, hey, get me all of the wired modems and then wrap them all or something like that. We'll come up with it in time. The next thing that the code does when it runs this, the first thing it does is do screen.clear. And when we do screen.clear, it removes all the details here because we've written them. We've written all the text in here, but we have to tell it to remove the text upon the next time we want to run the code. Otherwise, it would overwrite letters, but let's say this was only, let's say the thing that was in here only had 4 letters. We would overwrite the first 4 letters, but the rest would remain, which would look bad. So we got to make sure we clear it all away. And then, this is a loop. So for loop, we're starting at index value 1. And then this says, for however many lines, right, or however many records, this is a count of records in line. We passed in line, right? And the line itself is, if we remember, if we come back up here, it's just a number value. We passed in line 4. This was the last time we ran the code. It's going to have 6, 10, and 13. That's all that's in there. So this says index starting at 1 for 3. There are 3 lines, do. And the first thing we do is we set a display name. This is a variable. So we're doing the drawer controller dot get item detail of line number 1, because we start with 1, right? Dot display name, that's what it says over there. And then we print the display name, and the display name of line number, line position 1 is the weathered limestone. We do the same thing for count, the very same thing for limit, except this is a different function call of get item limit. And then we're creating a percentage value of the count divided by the limit times 100. So, then this is some temporary monitor testing down here. If I equals 1, this is where I've said this is drawer 1 of the line, this is drawer 2 of the line, and this is drawer 3 of the line. They go from bottom to top, which does mean that I have to very specifically start at the bottom and go up when I'm writing the text on the screen. So we say if the line, if the item in that line is item number 1, the bottom drawer, then we need to set the screen cursor position, right, where we start typing. We have to set that to 128. And this is an X value, and this is a Y value. 1 is the very first pixel on the left, right, all the way up. That is 1. 28. So this is actually, there are 28 pixels all the way from the top down to here, where that W is. This is line 128. So that's where we're going to start printing the very first thing we do. If this was the second item in that list, we would set it at 114, and if it was the third, it would be 11. That is 114, and that is 11 right up there. So what do? We do screen.write display name, and then we have to get our X and Y position of the cursor where we would print next if we were to tell it to write anything else. And what we want to do is we want to get the next line. And in order to get the next line, we use the Y position from the get cursor call, which we know, right? We're actually on line 28, but we know we're at line 28 here. We would do 28. The Y position value variable becomes 28 plus 1, which is now 29. And so then we do screen.set cursor position of 1. So we go back to the left of the screen. We go down 1 row, and then we write the count. And we do the same thing again. Back to the left of the screen, down a row, write the limit. We do the same thing for everything up through %. But this is a loop. Remember, that was only for index value 1. Now we're going to do index value 2, and then we're going to do index value 3. So we would do 10 and then 13. But we wouldn't ever go on to 4 because the line only has 3 objects. So once it does 3, it stops. And that's how we write all of this out. And this is the basis of what our code will do. We'll have, again, a monitor setup. In fact, I will actually lay a few of these out just so we can have a better idea of what it's going to look like. Each monitor will correspond to the thing on the left is what I'm going to do, because the text is going to be left aligned. this one here is just temporary. We're actually going to move it over here when we're ready. Then this one will go right here. Oh, there's a torch there. Haha, couldn't place there for some reason. It was a valid reason. Aha! So now we will have all these monitors. We'll be able to see all these displays. And we're going to have to write code that updates, right? So we've printed this once, but you'll notice if I come here and I take out my, my cobbled ether stone, right? Because we're actually doing this one. If I take any numbers out of there, it didn't update the screen. So we will actually need to write code that monitors the drawers, right? And then periodically updates the screens so that it can stay up to date. And then the next bit of code will be how it interacts with the lines outside. We don't have the lines outside built, but we're gonna have a wireless modem on this, and it's gonna send a message. It's gonna say, hey, line number 4. Gather more cobbled ether stone, and it's going to be a message, and then a computer out there with a wireless modem will hear that message, and it'll say, hey, I am line 4. I know how to get cobbled ether stone. I'm going to go all the way out there and harvest it, and then we have to write the code to harvest as well. It's going to be a big project. It's going to be a lot of fun. The computers are expensive, though, so I don't know how fast we will be able to get to all of the different lines, but again, this project for me is super fun. I hope it's super fun for you as well. And once it's up and running, I think it's going to look kind of impressive. One more detail here. Once we move this screen over here, I want to put a bigger screen right here that connects to the computer. And this bigger screen will detail the lines. It'll say like line 1 running, or line 1 gathering cobblestone, or line 1 error, and it'll be in red or something like that. That would be pretty cool. You can't really do colors on these ones, but if you upgrade them to the advanced gold versions, you can do colors. So it might be something that we do, something that'll look cool. And we'll probably have like control switches and whatnot in here, maybe buttons on the screen that you can come up and punch. And that'll say like abort or reset line or something like that in case we do run into error faults. We have now exhausted our time for this episode. I'm really happy. Ooh, super zoom. I'm really happy with the progress we've made today. There was a lot of craft work behind the scenes in order to get these monitors and the computer and that kind of stuff. And so I am so ready for automation. So that will be coming. It'll be coming soon. TM, trademark, soon, you know. So again, thank you for watching. I really appreciate it. And again, please let me know. Do you like seeing the computer craft stuff? I have at least another episode or 2 of computer craft content that's coming through. So if we want to see the code, I'll show it. If we don't, I'll show the build and how it works, but nothing more. If you enjoyed this content, consider dropping that subscribe. But otherwise, have a nice day, nice night, nice week. This is Merxerain signing off.